Here's the second duration problem. Again, recall that duration measures the magnitude of the inverse relationship between bond prices and bond yields. As bond yields go up, bond prices go down, and duration is telling us by what amount do bond prices go down. In previous video, we've shown the formula for duration. Again, it looks a little messy. We're going to work another problem here. It should help you understand this a little bit better. I've kind of identified 3 steps to calculate this duration formula. The first and third steps are the easy ones. The second step is a little more tricky. In the first step, we're going to calculate the bond price, or the denominator of this duration formula. The second step, we calculate this numerator. It gets a little messy, so we'll slow down here. And then the third step is easy. We just divide the numerator by the denominator and get duration. Once we do this, after this problem, we'll talk about the implications of duration. Hopefully it will help you gain a conceptual grasp of why duration is important. In this second problem, you can read, suppose a $1,000 face value bond that matures in 2 years has a coupon rate of 7%. If the yield to maturity on this bond is 7.7%, what is the bond's duration? Again, the first step is to calculate the bond price. A couple of interesting features in this problem. We see that the yield to maturity on this bond is greater than the coupon rate. The firm specifies the coupon rate and thinks that it's about 7% per year risky. But the market is saying to this particular firm that's issuing these bonds that this particular bond is riskier than the 7%, suggesting that the market will only buy this bond at a discount. So we're going to calculate the bond price, and intuition tells us that this bond price should be less than $1,000. Like all of the bonds that we've worked on thus far, the face value or future value is going to be negative 1,000. It's negative because it's an outflow to the firm. From the firm's perspective, the firm has to pay out the $1,000 at the end of maturity. The payment here is the coupon payment. The coupon payment is 7% of the $1,000. It's also a negative $70. That's going to be paid out next year and the year after next year. It's negative because, again, it's an outflow from the firm's perspective. Maturity, the bond matures in 2 years, so N is equal to 2, and I over Y is equal to 7.7. Okay, we're going to enter this into our financial calculator and get the bond price. Negative $1,000 future value, negative $70 payment. Notice that in the problem, I don't specify anything about the coupons being paid out semi-annually or quarterly, so we assume that they're just paid out annually. So the payment is negative 70. N is equal to 2. I over Y is equal to 7.7. Compute the bond price. And I get a bond price of $987.4656. So that's the bond price. That's the denominator of this duration formula. The numerator is a little more tricky. So moving on to step 2, the cash flows look something like this. In year 1, the bond will pay out a coupon of $70. In year 2, the bond will pay out not only the coupon of $70, but we'll also have to pay off the principal of these bonds, which is $1,000. So year 2's cash flow is $1,070. Notice in the numerator of this formula here, we're going to take these cash flows that I've just specified in years 1 and 2. I'm going to take the present value of these cash flows, divide by 1 plus yield to maturity raised to the power of t. I'm then going to multiply by t, and then I'm going to add because I got to follow the orders of operation. So let's do this here real quick. So I'm going to take the present value. I have $70 divided by 1.077. So this is going to be the present value. I'm going to raise that denominator to the power of 1. So this here is the present value of the first year's cash flow from this bond, or the present value of the $70 coupon that's going to be paid out 1 year from today. Notice that I have to multiply that by t, where t is the length of the discounting period for this particular cash flow. So I'm going to multiply that by the same thing as t here in the exponent, in the denominator. So that's 1. I'm going to do the same thing for the second year's cash flow, which is $1,070. That's the $1,000 face value plus the $70 coupon. I'm going to divide that by 1.077, or 1 plus R raised to the power of 2. I'm discounting this second year's cash flow back 2 years. I've got to multiply that by T. Remember, I just raised this guy to the power of 2. So T equals 2 here. I discount this back 2 years, so T equals 2. So I multiply that by 2. Let's do this on our calculator. I got to follow my order of operation. I'm going to here in the numerator, I'm going to start with parentheses, exponents, then I'm going to divide, then I'm going to multiply, then I'm going to add. So let's do this. I'm going to say 1.077 raised to the power of 1 equals 1.077. So I'm working here in parentheses first, exponents. I'm then going to take $70, the $70 coupon paid out in the first year, divided by, my calculator stored that denominator. I hit second answer. See how it stored that denominator? I hit equals again, and I get 64.9954. This is going to be the present value of that first coupon. So I'm going to put this guy down here. Sorry, I was writing it down. So this first part of the numerator is equal to 64.9954. And I multiplied that by 1, and I got the same number there. I'm going to do the same thing for the second year's cash flow. I got 1.077 raised to the power of 2 equals 1.1599. That's my denominator in the numerator. This is what I'm going to divide the second year's cash flow by. My calculator will save that guy, so I'm going to say 1,070, the second year's cash flow, divided by second answer. So it saved my my previous answer. I hit equals again, and this is going to be the present value of the second year's cash flow, $922, 0.4703. Now notice I got to multiply that guy by 2. I still have to times that by T before I add. So I'm going to multiply this guy by 2. And I get 1844.9405. So I'm going to 1844.9405. Now I can add those two things together. Add that to the 64.9954, and I get a denominator equal to 1909.9359. Okay. So that guy right there is my numerator in the duration formula. The third step is easy. I'm just going to divide 1909.9359 by the price of the bond, 987.4656, and I get a duration of 1.9342. All right, now again, we've worked our way through this problem. Let's not forget conceptually what we're trying to do here. We're trying to measure the magnitude. If you assume that interest rates and subsequently bond yields are going to decrease by 1%, duration tells us that this particular bond's price is going to increase 1.93%. That is, for every 1% decrease in bond yields, this bond's price will increase 1.93%. And vice versa. If we expect interest rates or yields to go up, if yields go up 1%, this bond's price will decrease 1.93%.